The basic idea of distributed commit is going to be voting. And in fact, most of distributed systems protocols boil down one way or another to some kind of voting. In our case, we're voting to commit or abort transactions. How many votes do we need for a commit to win? If we're going to have a vote and we want to vote whether to commit, how many yes votes do we need to commit, and how many no votes would prevent us from committing? Well, note that any single node in our distributed database could observe a problem. A node might locally observe a deadlock cycle. A node might locally observe a constraint violation. And that node knows we should abort the transaction. Because any one node could know about an abort, it means that all nodes must agree to commit if we're to commit the transaction globally. So the vote for commitment has to be unanimous. All of the participants in the transaction have to vote to commit. So how will we implement this distributed voting protocol in the face of message and node failures and delays? Okay, we're going to use a scheme called two-phase commit. It's also known as 2PC, not to be confused with two-phase locking or 2PL. It's a completely different thing. It's very common when you're speaking to mistakenly say one instead of the other, but please keep in mind two-phase locking is a locking protocol for possibly even a single computer. Two-phase commit is a distributed commit protocol. Okay, two-phase commit works very much like the wedding ceremony, and Jim Gray famously used this analogy in an early paper on distributed transactions. In the first phase of the two-phase commit protocol, it's like when the officiant at the wedding says, do you take this man, do you take this woman, etc., to be your lawfully wedded spouse? So in phase one, the coordinator of the transaction, remember that every transaction had a coordinator? The coordinator tells all the participants to prepare to commit. The participants will respond with yes or no votes as to whether they want to commit. It has to be unanimous. And once all those votes are received, that's the end of phase one. The coordinator now knows the fate of the transaction. If all of the participants voted to commit, then phase two is that the coordinator says, I now pronounce you a committed transaction. Basically, the coordinator is going to disseminate the results of the vote to all of the participants in phase two. And then they can do the right thing, either commit or abort. But we'll need to do some logging to deal with the possibility that these participants or even the coordinator might fail during this commit protocol. So two-phase commit involves both a bunch of messages being sent back and forth between coordinator and participants and logging of those messages in the transaction log along the way. So we'll go through the details next. Here's the first part of two-phase commit. Phase one, the coordinator tells the participants to prepare. So the coordinator, of course, knows all the participants in the system, has to do it to be able to do a transaction, and it's going to send a prepare message to all of those participants. And then the participants will respond with their votes for the transaction, either yes or no. So in this picture, they're all going to vote yes. It needs to be unanimous for the vote to pass at the coordinator. Okay. Once the coordinator gets the votes, if there's any no, it's an abort. If they're all yeses, it's a commit. Okay. And at that point, we begin phase two. The coordinator is going to disseminate the result of the vote. In our example, the result was commit because everyone voted yes. So it disseminates that to all of the participants. And when the participants get that commit message, they have to let the coordinator know that they got it. So they'll send an acknowledgement back to the coordinator. And when the coordinator receives all of the acknowledgements from all of the participants, it knows the transaction is complete.